Okay, we're back. We're doing 9-7. We're doing part 2. This is where we are talking about all of the asymptotes for any of our particular graphs. So for our vertical ones, we're looking at the bottom being equal to 0. For the horizontal ones, we're looking at the power thing, and it's either the front coefficients, the front two numbers in front of the x's, or it's y equals 0 because the bottom has the bigger power. In this particular case, the bottom power is bigger, so y equals 0 is going to be the way we go for our horizontal. The vertical one, we have to put this equal to 0 down here, which means, again, we have to factor. So x minus 4, x plus 2, giving us x equal to 4 or negative 2 as our two vertical asymptotes. Set that one equal to 0. We got x minus 3 and x plus 2. So x equals positive 3 or x equals negative 2. So those are our vertical ones. Our horizontal ones, since we've got a 2 and a 2 here, it's going to be y equals 3 over 1, which is just 3. Alright, and again, setting our bottom equal to 0, it's going to be x minus 4, x plus 3. Getting kind of repetitive on all these because it's just factoring, which apparently is scary. So we're going to get x equal to positive 4 or negative 3 there. Our powers are the same again. These are 1s, so we're going to go with y equals negative 1 for our negative 1 over 1 here. Alright, this one equal to 0, so x is going to equal 5 or negative 2. Now, powers, is it really bigger on the top? No, because if we multiply this out, it's going to be 2x squared over x squared, minus 3x minus 10. So now our powers are the same, and we're going to go with 2 over 1, so y equals 2 is going to be our intercept there. Alright, let's factor some more. X plus 2, x plus 3. So x is going to equal negative 2 or negative 3. Powers are the same, so y is going to equal 1 for the two coefficients in the front. And, ooh, we got to actually subtract 4, get 2x equals negative 4, divide by 2. So x is going to equal negative 4 over 2 is negative 2. And again, our powers are the same, so we're going with those front coefficients, so y equals 1/2. Just like what we've been doing the last couple of days. Alright, lastly, finding our domain. Domain is what type of number can we plug in? And this comes back to our vertical asymptote. The vertical asymptote said, hey, this is the one number that you cannot plug in. That's what domain is asking. What can I plug in, what can't I? So we're going to do the exact same thing we did to find our asymptote, and that's going to be the one number that we can't plug in. Like say x can't be 2, because that's where our asymptote is at. And that's all the domain's going to ask us for here. So again, we're solving the bottom to equal to 0. Well, here it's just x equals 0, so our domain then is going to be x cannot be 0. That's the one number that we cannot plug in. So x not equal to 0. And that's what that would look like there. See, same asymptote going up and down. Can't go through 0 because this line will never touch it here, and this one will never touch it there. But anything going that direction, anything going that direction is something you can plug in, and you'll get an answer. Put that equal to 0, so x is going to equal negative 7. So our domain is going to be anything but negative 7. Simple, easy. Same things we've been doing. Let's add our 3 to the other side, get 6x equals 3, divide by 6. So x equals 1/2. So that's the one number that we cannot have. So it's the same thing you're doing for the asymptote, only now you put the little slash there and say, hey, we can't have that number. Uh-oh. Put that equal to 0. Subtract by 9, so I get x squared equals negative 9. Gotta take our square root of both sides. So we get x equals plus or minus the square root of negative 9. And you thought this went away, but no, it did not. Square root of 9 is 3, but the square root with the negative here means this is going to be x equals plus or minus 3i I. Okay, my eyes finally look cool now with this nice new pen. So plus or minus 3i. Is there any way that we were going to plug in an I here? Is that going to happen? No, it's imaginary. We're not going to plug that in. So that means this is all real numbers. Because the only one that doesn't work is imaginary. What does that graph look like then if it's going to be all real numbers? It's going to be this. Is there any vertical asymptote that it's not touching? No. It goes everywhere this way, and everything in between. It's kind of a boring graph, isn't it? Looks like a little hill. Alright, put this one equal to 0. We got I don't know, let's add 25 to both sides, so x squared equals 25. Take our square root of both sides, so x equals plus or minus 5. Means x cannot be plus or minus 5. And so here you can see where those asymptotes kind of are, the plus or the minus 5. Those are the two spots that we can't plug a number in. We can plug any of these in, any number in here, any number over here, and we'll get an answer because the graph is there. But we can't plug in -5 or +5. Alright, looks like we're going to have to factor again in order to solve this one for 0. So we got x minus 6 and x minus 2. 6 times 2 makes 12, and 6 plus 2 makes that 8. So x cannot be 6 or +2. Those are the two spots that our graph will not touch. And hey, there we go. Here's our 6, there's our 2, and you kind of follow it along here. Those are the two places that our graph is not going to work. We're getting answers in here, we're getting answers out left and right, but not on those two spots. And that's it. Make some good choices out there, and we'll see you back in class.